Energy Forum Support Office, and we are now directly digging into the topic of circular economy and repowering of wind turbines. So let me just please share some introductory slides. I don't know if it's possible that I get the rights to share the slides. So once again, welcome to the session on circular economy and repowering of wind. What are we going to talk about is gigawatts. Gigawatts globally. Bloomberg New Energy Finance last report, we were aware, October 2020. We are talking about around 4.5 gigawatt throughout the next numbers, including China. If you just look excluding China, you see a large chunk is now coming from the US and Germany actually, but then this purple part here is popping up, and this dark yellow part, Spain and India. And you see in India, we are also talking about gigawatts coming up to be foreseen to be repowered. And if we, which had been recently renewed and by structure, we see around a $10 billion wind market in India alone for repowering. Are you still seeing me? In India, more than 10 gigawatts of old, please, in India, more than 10 gigawatts of old wind turbines with less than 1 megawatt capacity are installed in the best wind-rich class 1 sites, no? And around 2.5 gigawatt with less than 500 kilowatt turbine capacity are presently installed in India. Huge opportunity. I'm really looking forward to the upcoming discussions with our speakers to dig deeper into this potential. And the other big topic we are touching in the session is about recycling, mainly recycling of blades, because it is known that around 85 to 90% of the wind turbine by weight can be recycled. But the two big challenges of the sector which remain are cost-effective recycling of the blades and designing the blades in a way that make them recyclable from the outset. So that's why I'm very delighted to know that Dr. Ishan Purit, from Energy Specialist from IFC, has agreed to join. Sri Shintan Shah, Director Technical IREDA, Ms. Annette Nüstlein, Board Member RDR Wind, Mr. Jaideep Malavia, Consultant NSEFI, and Mr. PK Prakash, Scientist D from MNIE. And with this, I'll hand over to you, Dr. Purohit.
Thank you very much. I hope I am audible to all. If somebody can confirm.
Of course.
So thank you very much, and please. So thank you very much, and sorry for this inconvenience. I'm not too much technology savvy on the systems, but yeah, the approach of the specific session, and it is well echo what I am talking about, but not solely on wind. You know, especially the repowering has been explored by industry since very long, and there are only few success stories what we can count, especially in India. So, but now actually we are exploring this opportunity slightly in different way. Because if you see in last 10 years, the way penetration of renewable energy has happened in India, now we are above than 100 gigawatt capacity on installed capacity. RE is comprising more than 25% capacity in overall installed capacity of the country. There is a graph. I have taken few glimpses on the slide. If you see the first one where two pie charts are there. So yeah, RE share is very attractive now. 10% is solar, 10% is wind, cumulative is more than 25%. But if we come towards generation side, then it is not too attractive, and our solar and wind combined contribution towards cumulative energy generation, it is nearby 10% only. I will say it is less than 10%. So where exactly we are targeting? If we are structuring a project or any policy is coming, or whatever targets we are setting through solar mission or other initiatives which are related with the climate commitments, those are in terms of megawatt. Recently, I have taken as a random approach. It might not be a very standard approach, but randomly on an average basis, if I see the performance of Indian solar and Indian wind power plants, so there is a graph of last 5-6 years. This data is of CEA, and the average plant load factor of wind is not more than 18%, except only in 1 year, 2018-19, it was there. And solar is in few years it becomes slightly above than 24%, but otherwise, if you see, it is in the moderate range. So while we are talking about multi-megawatt capacity, we started from 5 megawatt project. Now we are having 300, 400, that type of single project capacity. But if you see from generation point of view, we are not performing well, and which might be because of multiple reasons. I am making deep dive on solar side. So solar projects were till the capacity when it was up around 50 megawatt. Most of the projects was meeting the requirements. But when the project capacity increases from multi-megawatts, multi-blocks of 50 megawatt capacity, so lot of criticize has been there, seen the Bloomberg's report, and from portfolio assessment, I have seen that there is a significant deviation what is predicted and what plants are generating. From bankability perspective, in wind, we usually take a call. We consider P95, P90 for our disbursement, but in solar, most of the lenders across the country or globally, they still believe on P50, and they go with that number only. So repowering, actually, the approach, first of all, one can simply see that whatever has been predicted and whatever is the gap, first we can target that gap, because the structure is basically projects are having long-term PPAs. Initial projects are having very good tariff, and there is a firm PPA which is bankable, and PPA is defining their minimum and maximum limits. So in solar, there is some inherent degradation. There are some technical challenges. If you do the deep dive of why this performance is getting down, especially in the projects of moderate capacity, you will find that the resource is one of the biggest concern. And I'm sure that there might be some session on resource assessment as well. In wind, the process is well standardized in India, but in solar, it's still I would say most of the developers and lenders rely on the satellite data. And that is one of the reasons that our P50 deviation is 5 to 10% higher depending on the location. So that is one key concern for the difference in the generation. So third graph is basically giving, and we are just putting a layman type of approach. For example, my PPA is signed at the 25% plant load factor. I am at the 5th or 6th or 10th year of the plant operation. Every year I am facing around 0.7 to 1% degradation. There is some system unavailability. There might be some other kind of consideration. Sometime might be irradiance, sometime might be temperature, some time might be any other factor. And then my generation is on an average, I have seen even more than 10% lower generation, but I'm simply considering even 2 or 3% generation we consider. So if a plant of a megawatt size capacity, every year it is derating by at least 2%. And that 2%, when you are taking up to 10th year of operation or 8th year of operation, this gives a significant amount of potential. And please note that I am just targeting only the PPA limit. So in 2010, when the plants were of similar AC and DC capacity, if the plant has been degraded by 15 or 20% overall, then there is the potential of repowering will be in the megawatt capacity. And mostly all developers will obviously try to avail that benefit, and they might be doing that. So if we have seen from inception, all PPAs from NBBN to SECI to state governments, and then see that if we quantify the overall potential of repowering of solar plants only, we are having around 40 gigawatt capacity operational. And if only on an average 10% we can take, it will be a sizable capacity. But I am not taking a random approach. We have done deep dive, and we are able to quantify in order to meet the PPA requirement on a very safer side. If you are considering 2 to 2.5% loss, the cumulative potential of repowering in India around it is 5 to 7 gigawatt peak. That number we have quantified. This is one aspect which is well regulated, and we need to present to discoms, we need to present to the off-takers, and if they are able to see that, there are two aspects. One is the potential, there are existing PPAs, but parallelly I'm talking repowering, and repowering of solar and wind is slightly different. In solar, there is a nameplate capacity. We are not at all touching that nameplate capacity. We are only playing with the DC. And DC capacity we can certainly put in the existing premises of the plant if land is available, because I recall the days when solar has started, everybody was taking 5 to 6 acres per megawatt, and nowadays projects people are doing in the less than 3 acres per megawatt when the where the DC capacity is more than 50%. So it is basically approach of plant designing till the time of 10 years. Lot of technical advancements has happened, lot of new technologies to bifacial modules, and those technologies are available, including the string inverters, and they have given a lot of relax to the project designers to design the project in difficult trajectories. So if all these things are taken into account, so I will say that repowered energy will be the cheapest one across all renewable energy. That is basically we have found from our assessment. And if the most means the cheapest energy which is available within the plant premise, within the existing PPAs, so I will say this will be the lowest hanging fruit for the most of the stakeholders. But now, if we are thinking that, okay, there is a plant, we are repowering this up to a certain limit when it is meeting the PPA requirement, and he is getting paid for this one. Obviously, its business model will be very attractive. No rocket science on this one. But in today's scenario, when most of the developers are doing with the 65 to 70% of overloading in India. So if we have taken all plants from 2009, 2010, and in 2009-10, every people were doing 5% overloading because of the cost of modules, and n number of factors were there. Some policies were restricting on AC and DC equal capacities. And then gradually it has started. In 2015 or 16, 30% overloading was the general approach of the industry. But after that, when solar park and those kind of things, when SECI and other bids has allowed for higher PLF of the projects to sell to the off-taker, that point of time, 50% overloading becomes very, very common. So just taking a ballpark, 60% average of our total 40 gigawatt capacity portfolio, AC. So our repowering potential will be more than 45 to 50 gigawatt peak, which will be non-regulated. So if I have tried to show this through these two figures only, if I am doing within the PPA limit, that is basically regulated. This is the small portion. But if we are able to open it, and which is much relevant for wind especially, because in wind, before 2016, long-term PPAs like structure for SECI, those things are not existing. So, so if we quantify based on this approach, so I think we are able to unlock a market of, I will say the range of 5 gigawatt to 50 gigawatt peak. That is the existing potential one can see in the existing operational portfolio of the country as far as repowering of solar plants are considered. Parallelly, as I have shown from the second slide, wind performance, and this is the very layman approach. I have taken overall capacity. There might be projects in Karnataka or Tamil Nadu which might be performing very well. There might be some projects which are not performing. I'm just taking on an average plant load factor of wind in the country, which is 17% to 18%, which is as per the data available in the public domain. So, and whenever we do the due diligence or disbursement for wind power plants, so it is now 35% to 40% now what wind developers claims at P50, P90 values. So this is risky for investors. Parallelly, this is giving an additional window, because we have seen wind-to-wind repowering in India, which because of some reason may have not converged into success stories. Now, if we think that because solar is the cheapest energy in current scenario, if we think that whatever gap is there in wind dimension, wind PPA, if that gap could be filled by solar capacity, technically it might be challenging because we need to play with the nameplate capacity. There might be some regulatory intervention required. But then, because solar is macro resource and it is not too critically depend as wind on the resource. So whatever wind is performing, that is fine. And whatever gap is there, that we are targeting to do by solar. It may have its own challenges from land acquisition or some ROW, but some numbers we have quantified, which was coming even much attractive than what tariffs are there available in the market in current scenario. Even we take 2 rupees tariff for solar and wind, 2 rupee 30 paisa tariff is solar and wind. So it is less than 2 rupees what we are able to quantify, but wind is much specific. So moving on, next and my last slide on this. This is the, on nutshell, I'm just summarizing this one. There is minimum PPA limit, there is actual performance, there is maximum PPA limit. We are actually operating on this one, and even this range we are having a potential of 5 to 7 gigawatt only for solar. Similar number we are able to quantify for wind as well. So only from repowering within the existing regime of regulations, this kind of potential is existing. But if we are thinking to do beyond this one, because nowadays lot of initiatives has been taken by Government of India, especially on storage. So imagine that if there is a power plant which is operational, partial capacity it is selling to off-taker as per the existing PPA, and if it can go up to much higher capacity, because nowadays modern inverters are available, a plant which is at the 7 to 10 year of operation, they have to already replace the inverters, so they can easily repower this one. So cost wise or investment wise, it is not making big impact on the investors. The main thing is that if that is happened, so additional surplus capacity could be either stored through a typical battery pack, or they can simply sell to the third party to the market, and it may be taken as the cheapest electricity at that point of time. If daytime demand is there, that time it could be sold. Otherwise, uh, discoms or some third parties like RESCO or service provider on energy storage side, they can intervene in this area. So we are exploring all OPEX, CAPEX kind of model, but on a nutshell, with my final observation till the time, uh, mostly these PPAs are making this cap of maximum energy supply, but mostly the PPR is silent on if there is surplus energy generation, what is the provision. While some PPA or SECI is allowing third party sale is possible to do, but that quantum is very, very nominal. So no developer is doing at this point of time, as far as my knowledge is. But if this could be allowed, that you can repower your power plant up to the maximum technical capacity, up to 65 or 70% overloading. Obviously, one need to do technical commercials of that one. So it may open a new stream, and it may not only ensure the energy generation of the plant, but parallelly it can open business model for energy storage players. So with this, I will stop my my observations, and if there is any query, I will happy to take. Thank you very much.
Thank you very much, Dr. Purit from IFC. And with this, I would like to directly hand over, I think, to Ms. Annette Nüßlein, because Shintan Shaji from IREDA, Director Technical, I think he had to excuse himself. Or are you here with us today? No, then I would like to directly pass over to Ms. Annette Nüßlein. She is a board member of RDR Wind. Madam, over to you, please. Ms. Annette Nüßlein, I see you are here in the room, but we cannot hear you.
Can you understand me now?
Now we can hear you. Yeah, wonderful. Hello.
That's great. Yeah. I will share now the presentation.
Yeah, please go ahead. Yes, we can see it. And so if you would now go in presentation mode, please. Wonderful. Perfect.
Yeah.
Please go
Okay.
ahead. Floor is yours.
Yeah, thanks a lot. It's a great pleasure to be on board and to be a part of the 19th Wind Energy Conference in New Delhi. It's a great pleasure for me to introduce myself. I'm a board member of a new industrial association for repowering, dismantling, and recycling of wind turbines. We are based in Germany, in Hanover, and we have developed last year's standard for sustainable dismantling, disassembly, recycling, and recovery of wind turbines in the context of our new industrial association. The circular economy in the wind industry is extremely important for us, and we as a new industrial association, we want to do our best to address the circular economy to our relevant groups, to project developers, to utilities, to maintenance and service providers, and very important also to the dismantling and recycling businesses. Let me give me the chance to inform you a little bit about the situation in Germany. We have installed the first wind turbines 1986. And if you are familiar with the Husum wind and with the situation in Schleswig-Holstein, then you know that we have a lot of old wind turbines in the northern part of Germany. But to manage the energy transition in Germany, we need the more modern new wind turbines installed. So it's quite clear that until now we have installed up to 30,000 wind turbines. We need more efficient wind turbines and perhaps more wind turbines in the context of the circular economy. This next slide shows you that repowering and dismantling become more and more important in Germany because 33% of the wind turbines in Germany are older than 15 years. It's quite clear that not all dismantled wind turbines have been taken down because of the purpose of repowering. If turbines cannot longer be operated or repaired economically, then they will be usually dismantled. And if you're familiar with the wind industry in the last 10, 15, 20 years, the situation is that we have lost a few number of manufacturers onshore and offshore, and this caused a problem for the operators and for the service providers. So the continued operation of an old wind turbine is really a problem if the manufacturer no longer exists. It's quite clear that we have three options if you talk about repowering. Repowering is an option to install better and newer wind turbines. Continued operation with an old wind turbine is a business chance, perhaps to produce later on green hydrogen or decommissioning. While repowering requires planning and licensing permission, technical and economic aspects are crucial for the continued operation. That's relevant. Dismantling. Here in Germany, disused wind turbines must be dismantled rapidly at low cost and without compromising their environment or health and safety issue. That's very, very important. At present, disassembly by the dismantling teams is a complicated process. It takes a good 4 weeks to dismantle a single wind turbine. Our moderator mentioned this before, and this is really the good news. About 85 to 90% of a wind turbine can be recycled. However, there are still challenges and optimization potential in the context of the circular economy. We need more research and development, and we need fresh ideas and a sportive competition worldwide. It's quite clear that we have a legal framework for the dismantling and recycling of old wind turbines in Germany. But fact is, all plants are approved by the Building Supervisory Authority of each federal state. We have 16, and sometimes we have 16 solutions or regulations. Very important is our waste treatment regulation, the German Waste Treatment Act, the Commercial Waste Act, and special waste acts for oil, climate gases, etc. It's very important and relevant for all companies, also for the new companies which are willing to play a role in the decommissioning and recycling of wind turbines. They need information. Each dismantling project has its individual requirements. Technical information are indispensable. That's very, very important. And not only in Germany, also in Denmark or in other states of the world, we have a problem. We don't have enough information to organize the decommissioning and recycling in the context on the circular economy. Let me jump in and tell you a little bit more about our industrial association. We started in the context of a research and development project organized by a young project engineer in Hanover. We created a kind of round table and we built a network of repowering and dismantling experts. But after 3 years, it was quite clear that we have nothing in our hand, no checklist, no guidelines, no standard. And this was the beginning of our new industrial association. We started with 10 members and now we are 56. And it's quite clear our aim is to promote the dissemination of new technical applications and sustainable processes, standards, and norms. Last year, we published our standard in German and English, cost-free for everybody, a kind of handbook or guidelines or checklist or whatever to make decommissioning and recycling easier for everybody, for all operators or all service providers. I mentioned this before, we are very interested to work with other organizations and associations. We have a lot of members on board which are engaged in research and development, and we are quite sure that fresh ideas for the circular economy will be developed in the context of research and development or by startups or other engaged players in the wind industry. This is a list of our members. You can find more information on our website. We do our best to work with other associations here in Germany or in France or in Austria. We hold the contact to Wind Europe because Wind Europe is an extremely important organization also for the recycling of rotor blades or the decommissioning of onshore wind turbines. This is our Dean spec. You find the link in the link list at the end of the presentation. Please feel free to download our Dean spec, our standard for decommissioning and disassembly and recycling. It was very fruitful for us because the situation in Germany is sometimes a little bit difficult, that the German Environmental Agency was a member of our Dean spec consortium. This was extremely helpful, and we have spoken with a representative of the German Environmental Agency on Monday. We are really willing to move forward and develop, to walk together forward and create more solutions for the wind industry in Germany. I mentioned this before, the recycling rate for a windmill is really high, between 85 and 90%. The problem are the rotor blades, and we are really happy about an announcement made by Wind Europe. Wind industry calls for Europe-wide ban on landfilling turbine blades. It's quite clear that we can't waste resources. We must find a better solution for the recycling of rotor blades. And I'm really happy a number of manufacturers made an announcement in the last weeks that they will be able to create a more recyclable rotor blade in the future. I mentioned this before, it's important for the companies to have information. But fact is, we have a lack of information about the weights and contents of a specific wind turbine installed in Germany, in Denmark, in India, in China, in the US, or wherever. We have a lack of information about the available dismantling and recycling technology. We have the risk of unprofessional dismantling and recycling, and it's quite clear we need or we have to develop requirements for tender documents to make it easier for the companies which are involved in this area to organize the dismantling in a very professional way. If you let me jump in the DIN spec as a standard for operators based in Germany or service companies based in Germany. We have done our best to write or to develop or to make clear which kind of requirements are important for contractors. And health and safety is so important. We don't want to risk anything, and we want to make it as easy as possible for all the companies which are engaged in the process to understand that qualifications are necessary for the decommissioning and recycling of wind turbines. It's also very important to prepare dismantling and waste management concept. This is really extremely important to organize a professional dialogue also with all institutions which control the process. And we have more and more groups which protest against wind energy or protest against repowering. And if we can make clear that we do a good job in the beginning of a wind turbine in the decommissioning process, then it's easier to develop the wind energy in Germany in a very fruitful and productive way. We will move forward with our DIN spec. This is the reason why we are in contact with the German Institute for Standardization. We are also in contact with our partner associations and with Wind Europe. And yeah, it's very important to develop the industry-wide acceptance of the DIN spec and to move forward in the dialogue with all relevant stakeholders. I want to mention, this is also very important, that Wind Europe has submitted a report to the International Electrotechnical Commission, I think 2 years ago, and they plan an extension for decommissioning of wind turbines in a special document in the format of an ISC norm. I have integrated different links, so please feel free to use it if you want to get more information. We have in Germany different kind of onshore recycle wind projects, also one offshore recycle wind research and development project named SEEOFF, and you can read also more about circular economy in Germany. I've integrated also links about what's going on in Europe, excellent documents to learn more. The friends in UK have developed and published a wonderful document about recycling and circular economy. Yeah, please feel free to download the document. It's a tremendous help. And also the friends in the US, NREL is engaged in the circular economy. And so it's quite clear that the wind energy community, the wind energy family worldwide is active to make the wind industry greener and develop the wind industry in the context of the circular economy. So that was my presentation. Thanks a lot for your time.
Thank you very much, Ms. Nüsslein. That was very, very impressive. Actually, some people have asked, the DIN spec is already also translated into English, yeah?
Yes, this was extremely important for us. The 25 pages in German and 25 pages in English, cost-free for everybody. And I have done my best to spread the information through through LinkedIn worldwide, and also the World Wind Energy Association was so friendly and sent our press releases last year through, to all the members. Have integrated the link. The download is cost-free for everybody.
Yes, I think you just go to the specs are always free, and you just you also don't need to set up a user account, which is usually asking for. Just go directly to the download, and maybe Ms. Nüsslein, I don't know if you're able, this wonderful link collection, if you could maybe paste some of the links in the comment session, that would be really helpful for our audience. So that they can directly get your link collection. So if you would be able, that would be really nice. Just copy the links of your link presentation page and paste it in the Q&A if you would be able to do so. That would be really nice.
Yeah, I will do that.
Thank you very much, Ms. Nüsslein. Very impressive to know that there is an own proper association now for the aspect of circular economy. Thank you very much for this, for all these impressive insights. We're looking forward to receive your presentation and to get more insights crawling through the links. And with this, I'll hand over to Mr. Jaideep Malviya. He's a consultant, NSTFI, and he'll dig deeper into the topic of recycling from the Indian side. Over to you, Jaideep ji.
Good evening, good afternoon to everybody. Nice seeing you, Mr. Winter, after a long time, and the other August gathering. I have been working on the subject of more of recycling rather than, and repowering is a part of it. So instead of thermal, I will make it more on the solar energy recycling. I'll just share some of the findings which are there, and then I'll be open to any questions on that. Hope that is fine.
Please go ahead. Please go ahead.
All right. The topic is need for a strong legislative framework for solar waste management and solar waste management in India. Now that's roughly, the entire cycle of the solar energy system, right, as we call, from the cradle to the grave. That is right from mining up to the landfill. But here we are not asking for landfill, rather we are asking for reclaiming. That's the graph of the solar PV installations in India and the projections until 2030. Now, I believe the targets are revised to 500 gigawatt. So probably we may need to reframe or redraw our projections, because at the COP26, this was the announcement made by our Honorable Prime Minister. India currently stands fifth largest in terms of the solar energy installations, largely through solar PV. Solar thermal, of course, we have crossed the National Solar Mission target. We are way ahead of it, and we feature also amongst the top 10, largely through the solar water heaters. That's the component-wise breakup, per 1,000 kg of a typical photovoltaic glass panel or a module. So I won't go through the details because the presentations would be available later. But broadly speaking, the glass and the aluminum constitute about 88% by weight. And these are the two components which can be easily recycled and recovered. The other components are minor in terms of percentage, the third largest being the polymer substances and the backsheet, which are the most challenging thing, because they are primarily the polymer materials We don't have right now technologies to recycle, but they are equally toxic. A lot of R&D is undergoing. Perhaps one of the solutions to that is pyrolysis, which can be further used to convert into diesel. The recovery percentage. As we can see, anywhere between 90 to 95% the components can be recovered except for the backsheet or the polymer materials. The easiest of this is the aluminum frame. Aluminum can be easily deframed and it finds very good market in in the scrap value. So that's the most easiest thing. Silicon metal up to 95%, silver 95%, the glass containing antimony. This is one of the pollutant, although the amount of antimony is not as high so as to be classified under hazardous waste, but still when we talk of volumes, it can leach underground and contaminate the water. With time, the mass of the solar PV is reducing per megawatt or per capacity, meaning the efficiencies are improving, the raw material components are reducing. So, if we have to calculate in absolute terms, we'll have to be very, very careful how much we can recover after end of life. There cannot be a standard benchmark. So if we see modules prior to 2010, that's the year 2010, and that projected during 2030, they will almost be reduced by half. Environment impact. I think the graph is not being visible here. Contribution of PV module recycling is highest in the impact category climate change from transport, electric supply and waste disposal. Meaning we can avoid a lot many number of processes as against developing a virgin material by recycling the PV module. So recovery of glass, metals, semiconductor material causes lower environmental impacts than the extraction, refinement, and supply from the primary resources. We have now sufficient data available on this, and certainly this can help reduce the carbon footprint. Now, the previous speakers have been speaking about repowering, something that we call it as an early loss. It is very likely that in India, the solar PV projects that have come up may undergo fast repowering or may undergo early loss, largely due to the quality of the components used. Also because technologies are rapidly developing that provide higher efficiency. So as a result, once the investment cost is recovered, perhaps the investors may go for a repowering. So we anticipate an early loss. As you can see, that's the last highlighted one. And as well as due to the power loss, which is the performance loss of the modules may happen faster. These are few of the pictures of the damaged modules. We can have variety of ways, right from at the production end to due to the environmental impacts like hurricanes or due to vandalism by throwing of stones and other stuff, and also as a result of high gusty winds. Now, as per one of the studies undertaken by IRENA, India would be amongst the top 5 solar waste generators by the year 2050. Meaning by the year 2030, India will be amongst the top 5 PV power generators in the world. We will have the highest capacities. Hence, assuming a life of 20 years or maybe 25 years, by the year 2050 or 2055, India will have in fact one of the will be amongst the top 5 solar waste generators. In fact, if you see the graph in green, which is the early loss, India is likely to suffer fastest early loss. We are already undertaking one study on this, and there are positive results that yes, early loss may happen faster. Now, if the solar waste are left untreated and if they are stacked in the containers, if you see the map of India, virtually it can occupy the roads all over the country, all the 4 corners. So it will be difficult for the mobility or the transport to happen, and it will be also not feasible to landfill them. In any case, now the landfill has been banned by way of an order by the Minister of Environment and Forest because the components have toxicity which can leach the groundwater. So it makes it imperative that we have to recycle the solar waste. Not only recycle, but perhaps reclaim. And why not reclaim? If we can reclaim, we can follow the path of the Atmanirbhar, which is the new mantra in our country, meaning try being rather more domestic, manufacture locally, and produce power nationally. So if we see the statistics by the year 2050, we will have close to about 7.5 million tons. I've used the Indian figures here in terms of lakhs and crores. So almost about 7.5 million tons is what will have to be treated. Maybe more perhaps if our targets are revised. As I said earlier, why we should recycle in order to reclaim the materials. This is a simple table which gives us how much amount of material can be recovered if appropriate recycling technologies are developed. Today, that's also a challenge. Except for Europe, nowhere are still, there are mandatory laws that require solar waste management to be recycled. That's why there is very little experience how these materials would be recovered. But there are preliminary indications that they can be recovered anywhere between 90% to 100%. So here are the volumes that would be available in terms of tons. Now the common 3 R's used are reduce, reuse, and recycle. But we are not asking to reduce the use of solar power. Rather, we have redefined the 3 R's as recycle, reuse, regenerate, or reject. We want to regenerate or we want to reject and landfill. So that's a option left to the end user, or perhaps if the extended producer responsibility is implemented, which means one who is a producer has to take back, then either he can reject or regenerate. I'm sure all the producers would prefer the first option of regenerating. Currently, the questions to be asked, most important, should there be a legislative mechanism for recycling? Unfortunately, the Ministry of New and Renewable Energy has constituted a task force, of which I am also a member, and I am heading one of the subcommittees. Should the owners of recycling be with the manufacturers as EPR or the extended producer responsibility? Should PV waste be discarded in landfill or extracted? Will municipal bodies accept solar PV waste considering the volumes? Should there be a benchmark for buying of solar PV waste? More needs to be done. Analyze the real-time emissions of a typical solar PV, right from material procuring to landfill disposal, estimate the quantum of early loss, the legislative framework that has to be, in fact, on the topmost priority to be worked. Owing to vast geography of the country, we'll have to explore some portable means. There cannot be a central recycling. Otherwise, the logistics cost would be so high, it may make unviable Not only that, but it will equally contribute to the emissions by way of logistics. Form a consortium of PV module manufacturers to support a solar waste recycling not-for-profit organization. So now I am in the process of starting a producer responsibility organization, which will be a consortium of all the panel manufacturers, whether they are PV or thermal, and all their solar energy waste would be managed. Estimate the local job creations and identify the socio-economic benefits. My last slide. Again, as I said, why landfill when we can repower and create jobs? So let's repower and help fulfill the national goals of achieving the solar PV of either 350 gigawatt or 500 gigawatt as may be. Thank you very much.
Thank you very much, Jaidev Ji, for your impressive presentation, and also once again thank you to Ms. Nisline. For all of you seeing the chat, there is now this link collection being made available, so everyone interested can just go there and check the links out, and I think all presentations anyhow will be made available afterwards. And now it's my pleasure to announce the presentation of Dr. Pravya Kumar Das. He is the Scientist D at the Ministry of New and Renewable Energy, Government of India. Over to you, Dr. Das.
Thank you so much, Mr. Winter, and good evening to all the esteemed panelists. I hope I am audible, right?
Yes, sir. Please switch on the camera.
Perfect, yes.
So my PPT is visible now?
Not yet, sir.
It's loading. Yeah, now it's visible, but it is not in presentation mode yet. So, or maybe on the bottom line, no, on the very right, left to this 82% sign. Yeah, if you, yes, correct. Wonderful. Please
Okay,
go
thank
ahead,
you.
Dr. Dash.
Thank you for giving me this platform to share my views. I'll focus on repowering in wind energy sector in India. So this session is about recycling and repowering. So a lot of things spoken about recycling in wind, recycling in solar. And my friend Ishan has already spoken about the repowering concept in solar, although he touched upon the wind. So right now I'm working in wind energy division. So I will give my thoughts on the repowering, how it will be done, or what are the perspectives in India for the repowering of wind farms, which are already been commissioned 15 to 20 years back. So, and so as on this 31st October, India has already achieved more than 100 gigawatt. It is 103 gigawatts of renewable energy power, out of which 40 gigawatt comes from wind. And globally, India stands fourth position in wind energy installation capacity. Last year, we have produced more than 60 billion units of electricity from the installed wind capacity. And currently, the wind energy sector contributes to more than 4% of the total electricity generation in India. And the unit size of these turbines has gone up to 3.6 megawatt. So, which were initially in the sub megawatt level, that was around 250 kilowatt only. Now we have the machines, unit size machines, which are up to 3.6 megawatts. So right now, the wind energy sector mainly driven by the incentives. There is no direct financial benefits from the central ministry, but we can say the incentives through other way, like we allow FDI up to 100% to wind sector. The interstate transmission charges are waived off for wind projects, and this will be valid up to 30th June 2025. And we have already declared a trajectory RPO, renewable purchase obligation trajectory is there, which in fact, by around gives a obligation of 10.5% of their energy. I mean, the obligated entity, which are primarily the discoms, distribution company. So they have to procure around 10.5% of their energy from non-solar, and these non-solar primarily coming from the wind. And these new transmission lines are being laid by our central transmission utility, and primarily we plan it in those areas which are rich in wind. And we have also issued orders that this power shall be dispatched against letter of credit. This is more to give the financial guarantee to the generator that their payment will not be defaulted. And then we have a provision of providing concessional custom duties on certain components in order to promote these manufacturing of wind turbines within India. And our technical institute, which is National Institute of Wind Energy, which is actually providing the technical support along with the resource assessment and resource data to the developers. So these are the basic support right now we are providing to the sector. And coming to the tariff, we can see, I mean, from 2010 and 11, so wind is more or less flat. I mean, from that point also, the tariff was around 3.14 rupees per hour. Level of grid. Grid parity was more or less achieved from that point of time. So wind was kind of market driven. So no much support was needed for this sector. Whereas solar was very high at that point of time, more than 10 rupees or so. So more focus went to solar, to how to subsidize and how to bring down the cost. And after announcement of solar mission and a lot of financial schemes were there, which eventually made solar, and I will say the technology breakthrough. I hope a lot of R&D activity went on globally to solar. The solar eventually became cheaper throughout the world. It is not a phenomenon which is specific to India. So after 17-18, as we can see, the solar and wind are more or less. In 2017, India switched over from the earlier regime, which was feed-in tariff, to the auction regime. So right now, all these projects are being commissioned through a bidding mechanism. So this bidding mechanism eventually bring down the tariff from above 3 rupees to 2.5 or so. And our recent biddings, which shows the tariffs are more or less stabilized around 2.7 to 2.8 rupees per kilowatt hour. In fact, our last bidding is 2.69. So that's how the wind tariffs are now. But we can see the solar, in fact, gone below 2 rupees. So obviously all these discoms as of now prefer solar over wind because of advantage in the tariff. So now we need to change our focus to wind, and the last 3 years also the commissioning of wind was not that encouraging. In fact, in 2016-17, India achieved 5.5 gigawatt in that financial year, but after that we are commissioning around 2 gigawatts or so. So we need to do something in order to again bring the focus to the wind energy sector. And one of the thought is if we can go sector specific, like one is initially wind in the year 2010-11, most of these projects are coming from the MSME sector for captive consumption, and the capacity of these wind farms are below 50 megawatt. So 1 to 1.5 gigawatt of annual capacity were added from that sector. So if we can revive that sector, because our current bidding mechanism allows us to go for bidding for those farms which are capacity is above 50 megawatt only. That is a technical constraint for the ISTS connection. So there is nothing to promote or to encourage the commissioning of small size projects. So one thought is if we can revive that sector. And second is repowering, because most of our turbines, because our journey started from 1986. So 35 years back, we started our wind commissioning, and those days, these turbines are even less than 100 kilowatt. So, and they are also commissioned in the most windy areas. So we need to focus how those areas can be again utilized for higher efficient, higher capacity and efficient machines. So one of the sectors can be this repowering, and third is offshore. So these sector specific approaches are the need of our in order to revive this wind energy sector in India. Now coming to the current topic of repowering, the background is, as I say, our journey started in 1986 with a 55 kilowatt machine somewhere in Tamil Nadu. Now the size has been increased, the height also increased. So about 10 gigawatt of current capacity is less than 1 megawatt machines, and 2.5 is capacity less than 500 kilowatt. So lot of space we can free for our higher efficient machines. So the CUF of these old turbines are in the range below 15%, and these new turbines they claim they can achieve the CUF of around 35%. So a lot of efficiency you can bring into to utilize or exploit those natural resources available in those windy areas. The potential benefit would be we can betterly utilize those windy areas. Then operationally, we can reduce the operation and maintenance cost and the better integration with the grid. Sorry. Then the environmental and social issue, we can reduce the noise pollution, and financially, if we can, how to say, our land utilization will be better, and we can bring better economics to the sector. So what would be the strategy to first to start the sector? We need to first assess where are these farms, old farms are, and how many machines we can replace, or how many machines we can take off for repowering, how many areas we can free for these projects, and how to minimize the financial outgo while maximizing the project size and minimizing the resistance from the WTG owner. Because all these old projects, there are multiple stakeholders. So we cannot, go for a deal which is disadvantageous to them. So we have to strike a deal here where they will get the benefit, but we can also come up with a new project. Then we have to select the site with technically speaking where the repowering ratio will be very high. So those sites has to be taken off in the beginning. Then to identify the conditions like the turbine size, the age of the turbine, and CUF. Because why this is essential is because as of now there is no regulation which will actually restrict these wind farms to stop the wind farm and mandatorily go for repowering. So we have to do a we have to go for a affirmative actions right now, because no regulation is in place which will restrict them for further operation of those old wind farms. Then we have to develop a business model where this repowering will be attractive, not only for the developer, rather the developer, the regulator, and the ministry also. Because if this repowering will ask for a lot of money, so the ministry will also think of if this money can be better utilized for other projects in the wind sector itself. Why this thing will come? Because right now the India, we say the total potential is around 695 gigawatt, which is 700 gigawatt, but we have achieved only 40 gigawatt. So whether going for repowering will be a better option, or developing these greenfield projects will be a better option. So we need to also look into the economics of this repowering part. I have enumerated some of the issues of implementation, that the fragmented ownerships are there right now on these old projects. The land ownership also, there are multiple stakeholders. And what will happen to the captive status during the repowering process? And what will happen to the remaining period of the PPA? Because right now they have a PPA which is, let us say, for 20 years or 25 years, but the farm is, let us say, 15 years of operational. So 10 years remaining period is there. So what will happen to those 10 periods, on what rate, again, that remaining period will be counted, and what will happen to the additional energy, who will take it, at what rate you will take? So all these questions needs to be answered. And if it requires also additional evacuation facility, so how that evacuation facility will be built up, and what would be the economics of those facilities? Then one issue also be, let us say, as I said, there will be multiple stakeholder. Means in order to repower those sites, we need to have an aggregator. This aggregator will essentially talk to those multiple stakeholders and bring them to a single platform where their interest will be taken care of by some kind of equity or some kind of financial arrangement. And the new project should be have a PPA which is again viable for the project, or some kind of, if you require from some kind of financial assistance, can be thought of from the central minister or the state agencies. Then in that case, what would be the process of valuation of those old assets? Whether it will be a one-to-one thing, then the single aggregator has to deal with, let us say, 20 people in 20 different way, which makes the thing is very cumbersome. So should there be a guideline, or should there be a formula by which those old assets can be assessed or evaluated, which will essentially facilitate the aggregator? And we also need cooperation from the states to do this. So as I say, the first step to repowering would be to first identify which are the areas right now available for repowering of the wind sector. So to have a potential assessment through National Institute of Wind Energy, we have taken the case of Tamil Nadu, and they have mapped all those areas where the turbine size is less than 1 megawatt. So there are 4 areas, and one of the areas is Mupandil, where there is 804 megawatt of wind farms are exist where the machine size is less than 1 megawatt. So they have carried out a study, and that study suggests that area has more than 2,000 machines, less than 1 megawatt capacity for 800 megawatt wind farm, and for another 864 megawatt where the machine size is more than 1 megawatt. So there are 630 machines. So this particular area they have demarcated, and they have carried out a study if they will go for repowering. So what kind of result they will have? So this is the result they got. I mean, they have carried out the study in different configurations: 3D, 5D, 4D, 8D, then 5D, 7D, and the considerations here are different. One is if they can go for a repowering, in the sense that let us say 600 megawatt wind farm, they can increase it to more than 600 megawatt. As you can see here, that 800 megawatt capacity wind farm, this can be repowered up to 2100 megawatt. So the repowering ratio is 1:2.60, and they have taken the energy yield ratio. So that will give more than 4 times we can increase the energy generation from the same site. And similarly, they have taken other configurations, but as you can see, without even changing the evacuation infra, where they have gone for a 5D and 7D configuration. One of our ministry's guidelines suggests that the weight loss must be kept near to 10% only. So they have in fact designed the new repowered wind farm in such a way to keep the weight loss up to that extent. So in that configuration, they found this particular wind farm, without even changing the capacity, they have to only substitute those old machines with newer efficient machines, and wind farm capacity will be same, but this energy yield ratio can be increased from 1:1.77. I mean, 77% increase will be there in the energy output from the same machine. So that means we don't have to even augment the grid infra that in that particular farm. So what I intend to say is there is technical scope is there to increase the energy yield from that particular site, even not putting much money, except the cost which will be involved in dismantling of the old turbines. So if that 77% increase in energy yield that can be sold in the new discovered rates, whether the project will be viable or not. So that is the question based on which a business model needs to be developed. Obviously, these figures will change site specific. So for each site, we need to conduct this kind of studies to come up with the business case for repowering. So same study also, replicated for Tirunelveli, Theni, and Coimbatore. And as you can see, so we can achieve an energy yield ratio of more than 2 times always we can generate from the same site if we go for repowering. So what are the existing policy? In ministry, in fact, we have a policy in 2016, which says we can go for repowering for those turbines which are 1 megawatt and below. The only incentive we have provided in that policy is IREDA, which is our financing institution, will provide them the loan which will be 0.25% below the current rate which is provided to the onshore wind projects. So we have made the state nodal agencies as the implementing agency, and we also provided if the state needs to augment the grid evacuation infrastructure if it is required from the pooling station to the actual site. And this policy also talks of the in between while the repowering happens. So no penalty will be imposed for not providing power as per the existing PTA. And we have also waive off. We have a guideline on onshore wind energy which suggests that this micro siting should happen in 75D, but for repowering we have relaxed that condition. We say it should be site specific, and it is purely a technical parameter which will be only based on the developers calculations. So these kind of facilitation we try to do, and even government of Gujarat, government of Tamil Nadu, they also came up with some kind of policy. But till date, this particular sector has not picked up. That means there is some gap which needs to be filled up. So finally, what is in our mind is how to make this sector pick up is we need to, if we need to have a repowering project to happen. So this particular flow diagram shows how it should happen. These are the existing turbines. So it is not the case as we go for solar repowering. Solar repowering means they don't change the transformer capacity, they don't change the PPA, they don't need in fact another PPA. So whatever degradations happened in the past years, they just need to augment those degradation capacity through addition of new modules in the DC side of the farm, so that they can be within the plus or minus 10 or plus or minus 25, whatever the stipulation in the PPA. Within that range, they can repower the solar farm. But that cannot be replicated for wind. When we say repowering of a wind farm, essentially we mean it is a greenfield project. The old farm needs to be decommissioned and the same site will be utilized for a new wind farm. So in order to that happen, we need to decommission. So that decommissioning cost is the additional cost which is going into the project development. We have to see whatever the additional revenue can be generated through the additional generation of electricity, if that is sufficient to cover up this decommissioning cost or any grid augmentation cost, then that business case will come up. And or if that business case doesn't come automatically, some gap needs to be filled from the government. In fact, the ministry can think of supplementing that requirement. But we need to have those business cases where we need to know, okay, how much support is required for to make this sector work. So that's all from my side. Just one more. This is, as I said, right now there is no regulation which in fact restricting those old farms to cut off from the grid. So ministry right now is thinking of bringing a quality control order which will essentially assess the performance of all those old wind farms. If the performance is not up to a mark, so we will ask the grid operator to cut off the connection. So they will be, in fact, those wind farms will automatically go for repowering because they cannot push any energy to the grid. So we hope that this particular order, once it is issued, will give some kind of impetus to the repowering sector in India. So that's all from my side, and happy to take up any question if.
Excellent presentation, Dr. Dash. I was really impressed. Thank you very much also for showing the results from the Tamil Nadu repowering study. Thank you very much. Very impressive. I'd just like to check if Irina was able to join in the meanwhile. If not, any questions to the speakers? Excellent presentations. Once again, thank you very much.
Mr. Tobias.
Yes, please.
Last minute there was a requirement for Chintan to go for a meeting. So that's why he's not joining today.
Okay, sir.
Okay. Now,
shall we make a group photo of everyone, just like speakers?
Yes,
so maybe everyone with a camera, if you want, no? If you don't, leave it. But everyone who is still in the speakers hall, just or in the visiting hall, just turn on your cameras and we'll make a small screenshot. I don't know, Dr. Dash, if M&AE guidelines allow you to do so, I'm not sure. But whoever wants, just turn on the camera, and the organizing team might just... Mr. Prasadji, nice to see you. Namaste.
Nice to.
You're working so hard these last days and weeks, actually. No, weeks already. Yeah. Thank you so much for being here with us today.
No, thank you for taking the leadership. Thank you for taking the leadership in organizing this entire event on your own.
Miss Nusslein, are you still there? Frau Nusslein? Annette Nusslein? Maybe you can also switch on the camera. You make a... I saw also Miss Madhuri Negi. Maybe you can be there too.
Yes, of course. She has.
Yeah, for this, I would say the session is closed. Over to you, Mr. Prasad.
Okay, thank you. No, I am not doing anything. I just joined, listened, tried to understand a bit more, learned some things. But now it is for you to close the session as moderator. But I will talk to you offline separately for some other thing.
Wonderful. Wonderful. I think I made it clear in the beginning, even without China taking into account the repowering potential, we are talking gigawatts. Even in the next upcoming 10 years, each year we are talking about at least 3 to 4 gigawatt of repowering. In India itself, between half and 1 gigawatt each year. That's already quite some numbers if you take into account that in the last year it was around 2 gigawatt being commissioned new, no? So 1 gigawatt, 1.5 gigawatt being repowered. That is a huge numbers, huge business coming up. So thank you very much for each and every one for its contribution. Presentations will be able to be downloaded. Main links have been shared here in the chat. So thank you very much. Looking forward to see you again, and Pirmelenge.
That